If A, B, C, and D are 4 points on a plane and Q is the point of intersection of the lines joining the midpoints of AB and CD and BC and AD, then show that PA vector plus PB vector plus PC vector plus PD vector equals 4 times the vector PQ. Okay, let us begin. First, we'll try to understand the problem graphically. So here we'll be considering 4 points. So let's say the points are point A, point B, point C, and point D. Now, we have another point Q, which is going to be the point of intersection of the lines joining the midpoints of AB and CD. So that means if we join AB, then we're going to consider a point. Let's call this as the point E, which is going to be bisecting AB. Similarly, we will join point C and point D. And let's say we have another point F lying on CD such that it divides CD into ratio 1:1. Then we will be joining E and F. Next, we will take the midpoint of the but after joining AD. So let's say this midpoint is G. Then we will be joining C and B, and let's say its midpoint is H. So we will be joining G and H, and now we see that these two lines EF and GH are intersecting each other, and this point of intersection is the point Q. Fine. Now we have another point P. Let's say we have another point P. We'll consider the point P to be the origin of some coordinate system. So here we'll need to show that PA vector added to PV vector plus PD vector plus PC vector, that equals 4 times PQ vector. Now what we'll do to begin with, we will suppose that the position vector of these 4 points A, B, C, and D, let's say it's given by A vector, B vector, C vector, and D vector. So that would mean, this would simply mean that if we join point P and point A, then the position vector of point A is going to be the vector A, since P is the origin. Then we have PB vector given by the vector B. PC vector will be given by the vector C, and PD vector will be given by the vector D. Fine. Now we'll try to define the position vector of Q with respect to the points E and F. Now before doing that, we'll have to find out the coordinates of the midpoints E, F, G, and H. So here E divides AB in the ratio 1:1 internally. This simply means that PE vector, so PE vector will be given by A vector plus B vector whole divided by 2. Now next, if we consider the point F, so F divides DC in the ratio 1:1, which means that similarly we can define PF vector as C vector plus D vector divided by 2. We can also define the position vector of the point G. So PG vector will be A vector plus D vector divided by 2. And then position vector of H will be PH vector given by B vector plus C vector whole divided by 2. Fine. Now, in this particular case, ABCD is a quadrilateral, and we know for a fact that the lines formed by joining the midpoints of the opposite side of the quadrilateral are always going to bisect each other. That means we can say that EQ will be equals to QF. So we know for a fact that EQ equals QF, and also GQ will be equals to QH. Now this simply tells us that Q divides GH in the ratio 1:1, and Q also divides EF in the ratio 1:1. So again we can use the internal section formula to define the position vector of Q. That means that PQ vector is simply going to be, so here we'll be considering 1 multiplied to the position vector of E. So position vector of E we have already defined as PE vector, so that's A vector plus B vector divided by 2. We have A vector plus B vector divided by 2 added to 1 multiplied to the position vector of point F or PF. So that's going to be C vector plus D vector divided by 2. Fine. And we're going to divide this entire 2 vector with 1 plus 1. That means we now have A vector plus B vector plus C vector plus D vector whole divided by 4. So now if we cross multiply, then we get A vector plus B vector plus C vector plus D vector equals to 4 times PQ vector. However, we have already defined that A vector corresponds to PA vector, B corresponds to PB, C corresponds to PC, and D corresponds to PD vector. So let's substitute these values. So we have PA vector plus PB vector plus PC vector plus PD vector. That will be equals to 4 times the vector PQ, and this is what we were asked to verify. So we have successfully verified that if A, B, C, D are the 4 points in plane and Q is the point of intersection of the lines joining the midpoints of the side AB, CD and AD, BC, then it's true that PA vector plus PB vector plus PC vector plus PD vector equals 4PQ vector.